My name is BobBoyd. I'm a professor in the Department of Biological Sciences, and I'm also our undergraduate program officer. I tell them I'm a plant ecologist. A plant ecologist is someone who studies the relationship of plants to their environment. In particular, I'm interested in how plants and animals interact, at least for most of my work and most of my research. Broadly, I'm a plant ecologist, or a botanist, I suppose. I started more as a botanist, interested in plant ecology, interested in how plants and animals interact and the consequences for the evolution of both of those groups. I'm also a conservation biologist because I apply some of these to questions about rare and endangered plants. And I'm also interested in serpentine ecosystems, which have a particular kind of high metal rock that's a pretty bad substrate for plants to grow in. And so those plants have to have special adaptations, and one of those adaptations is metal hyperaccumulation, which I presume we'll talk about.
We will talk about that.
Matter of fact, there's my rock right up there.
Oh, hey.
Yeah, you want to grab my rock, my green one? Sweet, I can bring that on camera. So in terms of those other elements, we got a couple of stories. This is serpentine rock. Serpentine rock has got very low calcium levels, but also very high magnesium levels. And for most plants, the calcium-magnesium ratio in the soil is very important. They need a significant amount of calcium, less magnesium, and those elements are similar enough that if you got a lot of magnesium, it can interfere with calcium metabolism, and that's a problem. So here's a couple of elements that are pretty important for plants that these rocks and these soils make for challenging growth environments for plants. So plants can adapt to these sorts of things. One of the other things you're teaching your students is about evolution, of course, and natural selection and all those things. So plants adapt to that. Shows the other story with this kind of rock is that it often is high in chromium and nickel. Chromium and nickel are a couple of heavy metals, relatively minor constituents to most rocks in most situations, but when you get a lot of them, they can be toxic. And so the nickel hyperaccumulation story is that there's some plants that are able to basically detoxify nickel and place it in their tissues at high concentrations. The question ecologically is why they do that, what the natural selection advantage is. And the big thing that my lab has been involved in is whether or not it might be a defense against the plant's own enemies. And there's a fair amount of evidence that plants that hyperaccumulate are protected against herbivory and pathogens by the normal sorts of pathogens and herbivores that we find in these kinds of sites. There are some insects, and probably pathogens too, that have evolved to be able to attack these plants that use the high levels of nickel as a defense. And that's a really nice sort of turnabout ecological evolutionary story that we've been part of the scientific unveiling of, which is